Okay, thank you for joining. So today we're starting a new unit, which is Unit 7, Method and Tools for Analysis. I think I got the wrong file. Um, okay, all right, just 1 second. Um, I can't find the unit specification here. So this is Unit 7 for Level 4 Diploma in Computing. So in this unit, we're now going to dive into methods and tools for analysis. So what are we going to cover from this unit? We're now going to help our learners to develop an understanding of method used in data analysis, and also what the common tools, skills that are required when it comes to data analysis. We'll also look into the approach to this role of data, which every data analyst is required to have. So let's going to understand what a data analyst does. So data analysis is simply the process of collecting data, raw data, where we're now going to cleanse, inspect, and transform this data into useful information. And we can now draw reports. These reports are going to give some insights to our company, which will now going to help us, is going to support the company board of directors for their decision making. So data analysis is a very emerging technology sector, which can now which is now across multiple industries such as healthcare, pharmaceutical, finance, many other industries. So now we're going to discuss the common methods and tools used in data analysis. So to understand data analysis, we need to really look into probability and statistics, where we're now going to have the ability to summarize and describe the main features of data sets. So by having the ability to involve in these measures, we can now measure of variability, such as range, variance, and standard deviations. Once we've now gathered our information, we can now describe the statistic and provide a simple summary about the sample and the measures. So when it comes to statistics, we have various types of them. It branches in various types of statistics. For example, we're now going to look at inferential statistics, which goes beyond describing our data. So with this, we now use it to make inferences about the population based on sample. So this will now going to include hypothesis testing, confidence intervals, and regression analysis. So this will now help us to determine the probability that an observed difference between groups is a dependable one, or that might have happened by chance. So this inferential statistic allows us very much to understand probability. Then we have predictive analysis, where we're simply going to use statistical algorithms and machine learning to now identify the likelihood of a future outcome. So these techniques are now going to include regression analysis, decision trees, and a neural network. Qualitative data analysis is now going to involve non-numerical data, such as text, video, or audio. So this is very much structured data. And this method will now content analysis, thematical analysis, and narrative analysis. Also, we have exploratory data analysis, which is the approach from analyzing data sets to summarize the main characteristics, often using visual methods. So, for example, once we're doing visualization, once we have roughly gathered our data, we've now transformed them. We can now use graphical visualization to see our results. So this technique will now include plotting or histogram. So this is very important for discovering patterns, spotting anomalies, framing hypotheses, and checking any sort of assumption. So when it comes to a data analyst, there are various frameworks, various tools that are very essential for the day-to-day activity of a data analyst. So we can start off with Microsoft Excel, which is widely used, and it is accessible and user-friendly interface. So Microsoft Excel is now going to provide tools for data manipulation, statistical analysis, and data visualization. When it comes to the programming side of it, we now have to have the ability to code with a programming language, which is more suitable to our project. So R is a programming language and software environment for statistical computing and graphics. It is also very highly extensible and provides a wide variety of statistical and graphical techniques. So R is often used for data analysis, statistical modeling, and data visualization. Python, which is the most common programming language when it comes to machine learning and data analysis. So this is a powerful programming language with extensive libraries such as NumPy, Pandas, Scalar, and all of them are now useful for data analysis and machine learning. Then we have IBM statistical package for the social sciences, which is another useful statistical analysis tool. It is user-friendly and it is also designed for social sciences. When it comes to data visualization, we can now look into Power BI, which is designed by Microsoft, or Tableau, which is a data visualization tool used for converting raw data into understandable format through visual representation. Then we also have SAS, Statistical Analysis System. And we know this is a software suitable for developed for advanced analytics, business intelligence, data management, and predictive analysis. When it comes to the theoretical frameworks in data analysis, we can look into a couple of these frameworks. And they're basically going to include the steps such as data collection, data cleaning, data exploration, data modeling, and data visualization, which we know that all these steps are now going to involve specific techniques and tools for ensuring data quality and reliability. Also, we have to look into cross-industry standard process for data mining. So what does this involve? This is going to be a widely used framework for data mining project. And it is broken down into 6 major phases, such as business understanding. After we now have a purpose of our business, we're now going to look into data understanding. We have now gathered our raw data, and we have to now prepare our raw data with our tools. We're now going to modeling, evaluating, and deploying our data. So this structured approach is going to ensure that we have now comprehensive data analysis and effective implementation. So to conclude this, we can now say that the common methods and tools used in data analysis are now going to be fundamental for effective data-driven and decision-making. So what are the common data analysis methods? We have real of data analysis, where we have several methods that are employed to handle and manipulate the data effectively. So these methods are going to ensure that data is prepared in a suitable format for analysis and interpretation. So some of them are now going to look into data extraction, where our extraction from production system or databases. So what do we mean by this? We're now going to have data extraction from production systems, which are going to involve retrieving data from operational databases or data warehouses. So this process normally employs the ability of working with SQL queries to pull data from relational databases such as MySQL or PostgreSQL or Oracle. We can also extract data from text files, which is now going to involve reading data stored in format like CSV file, JSON file, or XML files. So these are mainly used when it comes to data exchange and storage. And they're also particularly in environments where relational database are not feasible. Also, we can extract data from unstructured or semi-structured data. So when it comes for unstructured data, as we mentioned, this cannot be extracted from text to document, emails, or multimedia files. And when it comes to semi-structured data, these are now retrieved from JSON and XML, which are now required specialized methods for extraction. Also, we can extract from analytical system and databases. So after extraction, data is often loaded into the analytical system, a database designed for high performance analysis. Also, once we have now extracted our raw data, we have to now manipulate and transform this. So this is simply the process of cleansing, where we're now going to be removing duplicates and erroneous entries, filtering for defined subset, where filtering is now going to involve selecting a specific subset of data based on defined criteria. And this can now be done using SQL queries, pandas library in Python, or similar tools to include only relevant data for analysis. After we've now modeled, we can now convert our data type. So data is often need to be transformed into appropriate format for analysis. So this will now involve converting data type, such as changing string to integrate data to a standard format. Aggregation and summarization, where aggregation is going to involve combining data to provide summaries, such as a total, average, or count. So these steps is now essential for reducing data complexity and highlighting key trends. Merging. So we have different types of merging, such as horizontal and vertical merging. With the horizontal merging, we're now going to involve combining data sets side by side, typically by adding columns, while vertical merging will now involve stacking data sets on top of each other, typically by adding rows. Also, we need, when it comes to our database, we need to look into unique keys, primary and foreign. Well, with unique keys, these are now used to ensure that each record within our table is unique. And this allows us to prevent from any sort of duplicate. Primary key is our unique identifier for record in a table. For example, this could be customer ID. By providing the ID, we now have our primary key that allows us to identify all the attributes related to our record. Foreign key is now also used to link records between tables. So they are filled in one table that unique identifier, that uniquely identify a row in other tables. So common fields, when merging data sets, common fields, also known as joint keys, are used to align data correctly. To conclude this learning outcome, we now understand that this common data analysis method is crucial for effective handling and preparing data for further analysis. Here we have a summary table of the common data analysis methods that we've covered. We're now summarizing data extraction, where we have the description for each for them and the key techniques that are required for them. And this applies for data manipulation and transformation and merging. So we're now going to explain the purpose of each data analysis method with example. So explain what data extraction is about. We already said that the purpose of this is to extract the raw data that we now have to process and clean in order for us to have results. So example of them, extraction from production system or database, where companies can now retrieve sales data from the SQL database to analyze quarterly sales performance. Also, we have extraction from text file, which is an analyst download the CSV file containing surveys, response to analysis, customer satisfaction. When it comes to extraction from unstructured and semi-structured data, a researcher team will now use web scraping to collect the data from social media posts to discuss public opinion on a new product. Extraction from analytical system or databases, where after extracting data in them, after extraction, data is loaded into a data warehouse like Amazon Redshift for further analysis. Manipulation and transformation. We know that once we've now gathered our raw data, we can now transform, we can now cleanse and modify the data to ensure accuracy and consistency. Example for this, removing duplicate and erroneous entries. So the example for that is that an analyst cleanses the data by removing duplicates duplicate customers' records, and correcting invalid entries to ensure data accuracy. Filtering of defined subset. A marketing team filters customer data to include only those who made the purchase in the last year for a targeted campaign. Converting data type. A data scientist converts a column of data strings into datetime format in Python using pandas for time series analysis. Aggregation and summarization. A financial analyst uses SQL to group transaction data by month and calculate the total sales for each month. Merging data set involves combining data from different sources to create a comprehensive data set for analysis. Example of merging: when it comes to horizontal, an analyst combines customer demographical data with purchase history by matching customer ID to create a unified data set for segmentation analysis. Vertical merging: a researcher stacks survey response from multiple years into a single data set to analyze trend over time. Example for using unique keys, primary and foreign keys. We now have a database administrator which uses primary and foreign keys to link orders to customer in a relational database, ensuring data integrity. Common fields. We now have an HR analyst, which is going to merge employees' records from different departments using employees' IDs to analyze company-wide employee performance. Formatting. With formatting, we're now going to ensure that data consistency and readability by making it easy to analyze and interpret. So example for these are string formatting, where analysts will now use Python to replace function to standardize countries code in datasets. Data formatting. A data scientist is now going to convert data to standard format for consistency in time series analysis. Number formatting. An accountant formats financial data to display numbers with commas as thousands, separators, and 2 decimal places for clarity. When it comes to aggregation, this is now going to summarize data into meaningful metrics, facilitating easy interpretation and comparison. So, example for this, we have stratification and groups, where researcher groups patient by age range to study them in decent and quiz across different age group. Example function such as analyze tools sales by summing daily sales figures. Average is now going to calculate in the average set score of students in a class. Max and min is going to identify the highest and lowest temperature recorded in a month. First and last value is going to be tracking the first and last transaction of a customer to understand buy behavior. Visualization, we're now going to represent data visually to highlight patterns, trends, and insight that might be missed in raw data. Examples for that, we're now going to use charts, where a sales manager uses bars charts to compare monthly sales across different regions. Graphs, a data analyst employs scatter plots to identify correlation between advertising spend and sales revenues. Diagrams, the project manager uses a flowchart to map out the steps in a project workflow. Dashboards, the business analyst creates an interactive dashboard in Tableau to monitor key performance indicators, which are the KPI in real time. So to conclude the learning up regarding the examples, we can now say that each data analyst method and tool serves a distinct purpose in the broader context of data analysis. Now I'm going to describe the role of common tools in analysis. So we've looked into the tools such as Excel, SQL. We looked into programming language such as R and Python, and also our graphical visualization tools such as Power BI and Tableau. So when it comes to data analysis, we're now going to involve various of them for processing, cleaning, and manipulating data. So these tools enhance the efficiency and effectiveness of our data analysis tasks, which are now going to make it easier for analytics to derive meaningful insights from large data sets. So we're now going to describe the role of common tools using data analysis. So we now have tools for formatting, which are now going to be essential for preparing data in consistent and usable format. So what are the key features of formatting? We now have string formatting, where tools like Python string methods are now going to be used to manipulate textual data. So for example, standardizing case, we're going to converting all text to uppercase or replacing substring to correct or normalize data entries. Date formatting, where with data in Python, or Excel date function, these are now used to convert data into standard formats such as ISO 8601. Number formatting, so tools like Excel, Python are now going to locate modules for our formatting function, helping standardizing the representation of numbers. Aggregation tool, these are used to summarize and condense large data sets into meaningful metrics. Key functions are now going to use such as sum for aggregating data by summing up the values. Average is going to calculate the mean of data point, such as average test score. The student provides essential tendency measures. Max and min are now going to use to find a maximum and minimum values in our data set. First and last value are going to identify the first and last entry, such as first and last purchase date of a customer. This is very useful for tracking stratification and groups, where grouping data into categories allows for comparative analysis across different segments. And then visual tools such as Power BI and Tableau are critical for representing data into a visual format. This very much covers even charts and graphics. And again, we have visual tools are now chart, graphics, diagram, and dashboard. So now we have our merit learning outcome. We're now going to explain the use of visual methods to represent the outcome of analysis. So our visual methods that we just covered, such as chart, graphics, diagrams, and dashboard, we can now see that the use of our visual method are now very useful when it comes to report the outcome of our analysis. So these methods are now going to play a important role, and they can now transform complex data into understandable and insightful through graphics. So charts, we have different type of charts, such as bar chart, where we're now going to represent a categorical data with rectangular bars, where the length of the bar is proportional to the value of our variable. Line chart, with the line chart, we're now going to display data point connected by straight lines. They are particularly used for showing trends over time. Pie chart shows the proportion of the whole. Each slice represents a category's contribution to the total. Scatter plots is now going to display value from typically two variables from a set of data. They're useful for identifying correlation or relationship between variable. Histograms represent the distribution of numerical data by showing the numbers of data point of falls within specified range. Aerographs are similar to line chart, but with the area below the line filled in. So they're used for showing cumulative totals over time. When it comes to diagram, we now have flowcharts, which are now showing the process of workflow using various symbols represented in different steps. Network diagram, these are now going to illustrate relationship and connection between entities such as node and edge in the network. Dashboards are simply there, going to combine multiple visualization tools. So it's now going to combine multiple diagram or pies, for example, for an interactive interface, where it's now to provide a comprehensive view of key metrics and trends. So now let's look into the advantages of visual methods. These are now going to, again, as we said, simplify of complex data, where we're going to have a visual method, condense large and complex data into an easy interpretable format. enhanced communication, where with graphical representation are now going to engage more and easier to understand raw data. And now useful for quick decision making, where we have visual tools provided at a glance, with insight and enabling a faster, more informed decision making. Also, this helps for identification of trends and patterns. This allows us to visually see new methods, particularly line charts and scatter plots, will now help to recognize trend and correlation that might not be evident in a tabular data. So to conclude this, our merit learning outcome, we can now say that visual methods are indispensable in data analysis, and they enhance the clarity, comprehension, and communication of analytical tools. So this was everything for today's session. Is there any question for me? Okay, so if there is no any other question, we can now take 5 minutes break and join our learning outcome to meeting. Thank you.
Brilliant. Thank you, Victor. Yeah, no questions. It was all very clear. It's all, yeah, very what's the word? Yeah, it's what I do. I'm a data analyst, so yeah, it's all relevant stuff, all stuff I know. So yeah, all very clear. Yeah, I'll see you in the other meeting in 5 minutes.
Okay, thank you very much, and see you in the meeting.